We've got our last 5 questions from the practice final. We're going to solve the equation by the quadratic formula. List all solutions separated by commas. Our equation is 3z squared plus z plus 9 equals 2. Now, before we start solving, let's focus on the quadratic formula and understand what it is and how it works. So the quadratic formula is meant to solve quadratic equations. And your quadratic equation is going to be of the form ax squared plus bx plus c equals 0. It needs to be in this format to make sure that you can identify a, b, and c that are used in the formula. A is the coefficient of the squared term, b is the coefficient of the linear term, and c is the constant. So we must have the equation written with this equals 0 so we can identify that a, b, and c correctly. Now the formula itself is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So once we identify a, b, and c, we're going to plug it into this formula, and we're going to simplify that formula as much as possible. And we're going to follow order of operations. So with my equation here, I notice that I don't have the equals 0. So before I start using the formula, I need to subtract 2 on both sides. And now I have 3z squared plus z plus 7 equals 0. A is 3, b is 1, c is 7. So a is 3 because the coefficient of the squared term is 3. B is 1 because the coefficient of the linear term is 1. C is 7 because our constant is 7. Now let's plug these numbers into the quadratic formula. Now we'll give x equals negative 1 plus or minus the square root of 1 squared plus 4 times a, that's 4 times 3, times c, all over 2 times 3. We're going to simplify inside the radical. 1 squared is 1. 4 times 3 times 7. Let's see, 3 times 7 is 21. And 21 times 4 would be 84. 2 times 3 is 6. Inside the radical, we'll combine 1 and negative 84 to get negative 83. And inside the radical, we've got a negative. We can simplify the square root of negative 1 to be I. And I'm not sure if square root of 83 can be simplified. So I'm going to use my calculator and look for factors of 83 that are perfect squares. So perfect squares, 4 is a perfect square and it doesn't divide into 83. The next one is 9 and that doesn't divide. The next perfect square is 16. The next one is 25. The next one would be 36. And I'm checking all of these in my calculator. I tried 49. That's 7 squared. I tried 64. And that's the last one I'm going to try. So 83 doesn't have any perfect square factors, so I'm going to say that this is completely simplified. The question said list your solutions separated by commas, so one solution is negative 1 plus I squared of 83 over 6, and the other solution is negative 1 minus I squared of 83 over 6. For this question, we want to simplify the fraction x squared minus 7x plus 12 over x squared minus 16. A lot of people know how to simplify fractions by canceling common factors. And some people will be tempted to try to cancel these x squareds out. You're not allowed to do that because these x squareds are not factors. So in order to simplify this fraction, we have to factor the numerator and factor the denominator. And once we have it in factored form, we can look to see if there are any common factors to cancel out. So if I factor x squared minus 7x plus 12, x times x is x squared. Factors of 12, I can use 3 and 4, both of them being negative, and this will give us the correct factorization. Let me just double check before. X squared, x times x would give us the x squared. The outside would be negative 4x. The inside would be negative 3x, and if we add those together, that would give us the negative 7x. And then finally, this last one here, negative 3 times negative 4, is a positive 12. Then our denominator, x squared minus 16, this is a special format that we call difference of squares. A squared minus b squared always factors with the pattern a plus b times a minus b. So since 16 is 4 squared, I know that I can factor this as x plus 4 times x minus 4. Now that we've written it in factored form, I can see that I have a common factor of x minus 4. And then our simplified fraction is x minus 3 over x plus 4. On this question, we want to divide and simplify. We're dividing these two fractions. When we divide, we need to multiply by the reciprocal. So first, I'm going to rewrite this problem as a multiplication problem. You're going to keep, change to multiplication, and flip the last one here. That's creating the reciprocal. So our problem will be, our multiplication problem will be x squared minus 64 over x squared plus x minus 72 times x plus 9 over 2x. And now that it's a multiplication problem, I'm going to factor each part. This needs to be factored, and this needs to be factored. X plus 9 is already in factored form, and 2x is already in factored form. So x squared minus 64, that's a difference of squares, and I can factor that as x plus 8 times x minus 8. And x squared plus x minus 72, I can factor that into x and x. 72, I can use 9 times 8 with a plus on the 9 and a minus on the 8. Let's double check that one. The inside would be 9x, the outside would be negative 8x, which combine together to be a positive x. Positive 9 times negative 8 is a negative 72. So we factored that correctly. And now we're going to look for factors in common that we can cancel out. We have an x minus 8 in both the numerator and denominator, and x plus 9 in the numerator and denominator. So we can cancel those out, and we're left with x plus 8 over 2x. On this question, we want to add and simplify. We're adding fractions, 3/5 plus 5 over w. When we add fractions, we have to have the same denominator. We don't have the same denominator right now. So I'm going to make this fraction have the other denominator. And I'll do that by multiplying the other denominator on the top and on the bottom. So W over W is the same thing as 1. 1 times anything is just itself, so I'm allowed to multiply this W over W times 3/5. And then I'll take the second fraction, which is 5 over W, and I want to make it have the other denominator by multiplying by 5 over 5. 5 over 5 is the same thing as 1. 1 times anything is still the original fraction, so I'm allowed to multiply by this form of 1. So this gives 3W over 5W plus 25 over 5W. And now that they have the same denominator, I can keep that denominator and do the math on the numerator. 3W plus 25. Now those were not like terms, so we couldn't combine them together into a single term, but we could put them together in the numerator of the fraction. So our answer here is 3W plus 25 over 5W. For this question, we want to solve the equation 2 over x equals negative 9 over 3x minus 1. So we call this a rational equation because it has variables in the denominator. And when we solve equations like this, what we do is we look for the least common multiple of the denominator, so that's x and 3x. And that least common multiple will be 3x. X divides into 3x evenly, 3x divides into 3x evenly, so that's our least common multiple. We'll multiply that by every term, 2 over x times 3x, negative 9 over 3x times 3x, minus 1 times 3x. So this is called clearing fractions because once we do this multiplication, it's going to cancel out all of the denominators. Here in the first term, the x's cancel. In the second term, the 3's cancel and the x's cancel. And since that last term didn't have a denominator, there's nothing to cancel. So we have 6 equals negative 9 minus 3x. Now let's get x by itself. We'll add 9. 6 plus 9 is 15 equals negative 3x. And I'll divide by negative 3. X equals negative 5. Now you also need to do a check on this rational equation. And you're going to check to make sure that you're allowed to plug this number in. If I plug a negative 5 here, I'd be dividing by negative 5. If I plug a negative 5 here, I'd be dividing by negative 15. And those are both allowed. You're not allowed to divide by 0. Dividing by 0 is undefined. So in this problem, we've completed that check, and this is our solution, x equals negative 5. Thank you for checking out my videos. Have a great day.